Alright, so as we did last class, we did a little bit of introduction to trig and how we did a lot of review basically. This class it's a little different. We're gonna learn more about, actual trigonometry. We're gonna learn what's going on with trigonometry, and what makes this such a hard and challenging unit. So if you had friends that took math last semester, go ahead and ask them and they're like, oh no, trigonometry, I'm so scared of it. Well, that's okay. I'm gonna make it easy, I hope. So first I have this little table value here that I want to let you check out these values and to tell me if you notice any patterns. Just wanted to let you see that. So I have the angle from 15 increasing by 15 and we have the corresponding sine and cosine value. So I just wanted you guys to go and check out. Do you see any patterns? Well, if you don't, that's okay. So you will see 30 degrees has the same value as 150 degrees. 45 has the same as 135. And then 120, it's the same thing as 60, right? So this actually gives us a pattern. So it tells us this sine value, it's actually repeating. And that is exactly that is right. That is completely right. So sine is actually this. Something like this. It's gonna go and repeat itself continuously, essentially. It's a continuous value. And it's basically, well, it's a continuous value. So it's going to repeat itself over and over again. It's going to go over and over. And this is the only way how we're going to have a function that's going to give us the same value every so often. So now we actually just figured out what this means. So if I have this sine value repeating every around, you can see 30 to 150. Oh, what happened there? So, sorry. So if we had this value that repeats every 120 degrees, we actually can come up with a pattern. So right here on the very right, I have written this pattern out. Sine of 180 minus x is actually just equal to the same value. And cosine of 180 minus itself, it's negative cosine. So these values gives us actually one of the most fundamental rules of trigonometry. And that's the related functions, related values. And that is what we're going to learn today. So with related values, we can actually go ahead and explore what's going on. So as we said, cosine originally, if it takes a value below 90, it's always positive. And then when you have this value that's any value that's above 90, is going to be negative, right? And honestly, for grade 9 and 10, we've purely been dealing with positive angles that's 90 degrees. Well, less than 90 degrees. We're dealing with acute angles. So let's talk about obtuse angles today. So I'm gonna introduce you to this unit circle. So if you don't know what this means, it's 1, 2, 3, 4. That is the quadrants. So quadrant 1, quadrant 2, quadrant 3, quadrant 4, right? And now you might be wondering, hey, what is this ASTC? What does these mean? So it's actually the positivity of your corresponding functions. So in quadrant A, in quadrant 1, we have A here. That means that all trig functions, whether that being cosine, tangent, or sine, it's all going to be positive. And in the second quadrant, only sine is positive, while cosine is negative here. That matches our table. And then in quadrant 3, only tangent is positive. And then in quadrant 4, only cosine is positive. So there's two ways to remember this. It's either you go by the CAST rule, so C-A-S-T, or you go, oh, student, take calculus. That is how you remember this. So let's go ahead and get into this little idea of this first. So as earlier, right here, I showed you a circle. And there's a reason why we chose a circle anyways. So a circle, it's 360 degrees. You know that. I'm sure you do. So this means that when we actually separate this circle into 4 pieces, each of them is going to be 90 degrees, which matches to our trig here. However, even better, this means that we're actually able to build triangles within circles. So now, instead of having opposite hypotenuse and memorizing all of that, we actually have a new set of value here. So in the picture on the right, this shows you we have let's say we had so the 0.52 is on the terminal arm of an angle theta. So terminal arm, it's gonna be like any terminal arm is gonna be like this. So this is a terminal arm, or if you draw it even like an obtuse angle, this is also the terminal arm. So like this is where the angle stops. So we have drawn this out for you. I drawn it out for you. So we're gonna go ahead and have to find the sine and cosine ratio. So back in the days, we were like, hey, look, sine is opposite over hypotenuse. That still works now. But now we have different values. We have y over r. And I'm going to explain this in a second. And then cosine, it's actually equal to x over r, right? That is the adjacent over hypotenuse. So now there's a funny reason why we actually use x, y, and r. So this is because when we actually talk about coordinates, we can put this triangle on a Cartesian plane. So in 5-2, we're moving 5 units to the right, which means that is our x values. So x is actually equal to 5. And we move 12 units up, so that is the y value. So now, with that said, we can actually find out the r, otherwise known as the radius of the circle, by just simply doing Pythagoras theorem. So if we do 5 squared, which is 25, plus 144, let me just do that, 25 plus that's going to give us 169. And the square root of 169, we all know, is 13. So we have r is 13. So now we can just actually fill these values in. So sine of theta, sine theta is equal to y over r, 12 over 13. Cosine theta is equal to x over r, which is 5 over 13. And there we have it. That is the ratio. We can use either one of these to find the actual theta, but most of the times that is just calculator work. So teachers want you to show that you understand the question instead of actually just doing some calculator work. I mean, usually the teacher never really cares if you know how to compute it. They just care if you know how the question works. So now let's try something that is outside the first 90 degrees. So that we had O positive values. So now let's try something different. What if I have this negative 4 and 3? So this will be somewhere here, right? Negative 4 and 3. So we're going to go ahead and draw this length. Oh. I tried my best to draw a straight line. I'm sorry, guys. So what is a x value here? Negative 4. And what is a positive y value here? 3. So now we're actually I'm just going to prove this unit circle that I showed you earlier. I'm going to prove this. So you can see that when we have an angle here, cosine is actually going to be negative. So let's go ahead and write cosine. So, okay, first let's find r. Let's go by order. So 16 plus 9, 25. So we already know that's 5. So let's go ahead and do cosine. So what is cosine? Cosine, I already told you earlier. It was x over r. And sine was y over r. So in our case, x over r is actually literally just negative 4 over 5. And then this is 3 over 5. And you look at it and be like, hey, wait a minute. That is actually negative. So cosine of this angle right here, this theta, cosine of theta, it's actually negative here. So I just proved to you the unit circle, and I just proved to you it works. And now let's go ahead and just do some calculator work. I want to do this just so you know that you're actually using the degrees. And please, don't use radians. It will make you look like a fool. And I see it every single year that some student use radians and then they did the entire test wrong. So I want you to go ahead and enter to your calculator sine 133 degrees. With that said, and we have to round it to 4 decimal places, we're going to get 0.7313. And remember, we round to 4 decimals, so it was 73135. So we actually round up, so it's 0.7314. So let me write that, 0.7314. If you got a different answer, please check if your calculator is definitely not in the degrees mode. So go ahead and go online or look at the user manual of your calculator and be like, how do I switch this from degree to radians? Because that is a common problem that everybody has. And B, you're supposed to do cosine of 119.7 degrees as well. And you're going to get negative 4.9 0.545. So it's 4.955. Negative 0.4955. So remember that, see, this is still a negative value. So this continues to prove our unit circle to be correct. So sine of a value that is within the second quadrant. So first quadrant, I said this earlier, but I didn't say clearly. So this is 90, this is 90, this is 90, this is 90. I didn't say it clearly enough. So I thought people had enough simple algebra. So this was 0 degrees. This is 90. This is 180. This is 270. So so that's technically, well, realistically, the value of sine of an angle between 90 to 180, it should all be positive, right? So that is how you actually read this little circle. I just wanted to add that in here. And then let's go ahead and talk about number 4. We're going to try to find angle measures using a calculator. So basically, we're going to try to use inverse sine. So let's see. A. What we have to do is A is equal to sine, right? This is all we have to do. If you can't do this, okay, search your calculator for this first. You have to search your calculator for that. All right, and then we're gonna go ahead and enter that in here. So it should give you a bracket for you to enter a value. So we're gonna write 3, 2, 1, 4, and then you press enter, and that's gonna give you a degree. So in my case, that's gonna be 18.7 degrees. Round to the nearest tenth. Okay, so 18.7 degrees. However, remember this rule here. Now this comes into play. Sine of 180 minus itself. So basically, if I said sine of 18.7, that's going to give me this value. But however, another value is going to give you the same thing. So let's go ahead and do that. So 180 minus 18.7. 180 minus 18.7. That's going to be 161.3. And now, if we actually do sine of 161.3, it should give you 0.3214. So let's go ahead and try that. I'm going to try that. And that is correct. It gave me 0.3206, but that's because we rounded. We rounded the angles and stuff, right? So now let's go ahead and do cosine. So it should be the same. It should be the same process, the same idea, except for dealing with cosine now. Alright, so before we actually even do this, I want you to quickly ask you guys, what quadrant do you think this is? What is a possible angle? So we look at it and be like, hey, wait a minute, it has a negative value. So what does that mean? It's most definitely not in quadrant 1. It's most definitely not in quadrant 4 because cosine is positive here. So the only possibility is that it's in quadrant 2 or quadrant 3. So let's go ahead and verify that. Negative 0.5804. And then we're like, hey, whoa, it's 125 plus 4, 7, right? 125.5, because we have to round it to the 10th. So you're like, hey man, didn't you say there's another cosine value that's going to be equal to the same thing? Yes. However, we're not going to learn too much about that yet. So stay excited. And that is all for this lesson, I believe. So I want you guys to go ahead and try the homework on page 282 and 281. So that's 2 pages. So there aren't too many questions that I want you to really know, but I just want you to go ahead and try 9 and 10 and 11. So I'm going to actually copy that here so you can see it if you don't want to go look for it. So we have find 3 pairs of acute angles such that the sine of the first angle is equal to the cosine of the second angle. So we're setting up a simple algebra here, and then we're going to do and then you're going to supposed to find this pattern. So there's a little bit of pattern. Well, it really isn't that good of a pattern, but it's okay. It's good on memorizing. So you guys can use it to memorize, but really it's not like a mathematical procedure. And then 10 is asking you to do stuff to find the nearest tenth of a degree. So they want you to find A by giving you a terminal arm and a point. And then 11, they want you to find, I believe, they want you to obtuse in standard position. A point Q2 is on. Okay, so they want you to use the formulas that we learned earlier to, well, not the earlier ones, but they gave you two new formulas. Oh wait, no, that's not 11. So 11, they want you to find another terminal arm. So they want you to find how angles relate to each other. And then finally 12, we're going to prove these two. So they want us to prove those two, which they're correct, and you should memorize them. These are the ones that I learned. I told you earlier. These were the related question, related angles, and these ones are the correlated angles. I'm gonna make a lesson specifically next class, just purely on these two terms, and then how you should memorize them and all that. So that is pretty much it. So the main two difference, in fact, I'm gonna do it right now. So the thing is with related angles is that we're always gonna be switching. We're always gonna go from sine having, let's say, sine of an angle theta is equal to this numeric value. There's actually two theta. There's gonna be two values of theta that is gonna give you the same number if you enter the sine of it. So we already learned earlier 180 minus theta is going to equal to sine itself. There's more coming soon. There's more coming later. However, for correlated angles, we actually have sine of something, sine of theta. Let's say sine of 90 minus theta. That's actually going to give you cosine. So we're switching to from sine to cosine. And then that's the same thing for cosine. And then, even better, we have four main angles here. So 0, 90, 180, 270. So for us to actually use the related angles, we have to use 180 or 360. But however, we're only dealing with 180 right now. I just wanted to teach you guys a little ahead so you aren't that confused when we actually go in depth, or you go in depth next year and stuff like that. So we can do 180 minus x. That's going to give you sine itself. That's going to give itself. And then 360 minus x is also going to give itself. And then for cosine, it's the same type of thing. So if let's say I had an angle x here. 180 minus x is going to give me some sort of angle here, right? This full angle. So that is still positive for sine, because this is, remember, the cast rule. Right, always positive in this, and then sine is positive here, and tangent is positive here, cosine is positive here. So remember, we're using a lot of rules here. So sine will be still positive. However, cosine from from this part, it's gonna go negative. However, if sine is here and we do 360 minus that x, this is gonna be what we have. So that if we do 360 minus x, that is gonna be positive cosine x, right? So we're conversion here. That is not much to learn, but remember that everything you learn here matters, especially this question. Go ahead and prove that, and that is pretty much what we have. So I'm actually going to do this next class. I just want to give you guys a little, a little hint, wink, wink, and be like, this is what's up. This is going to be a little heads up. All right, if you have any questions, email me, find me, and I will help you.